Yes, this session is all about number system conversion. In this specific session, we are going to see how to convert a decimal into a binary, octal, and hexadecimal. So we know as the procedure traditionally what we have to do is we have to write those things in by using of pen and paper. So the same way we will see how the conversion will be. Just this is the recall of this concepts actually. So we will see how this decimal is converting into a binary. So the first, the value, the decimal value is 45. So if you want to convert that into a binary number system, we have to do division by using of this 2. And if you are dividing the 45 by 2 means we will get the remainder as 1. So likewise, we have to divide the entire number system until it gets 0. Then we have to write that answer in a reverse order. That is, this is a bottom up approach. We have to write that from bottom to top, and we have to put that 2 here at the base value because we are converting the decimal number system into binary. So if you want to do that, we have to divide the particular number by using of 2. The same the same like if you want to convert that particular decimal number into octal, we have to divide that particular number by using of 8. And the same way we have to write that number in a bottom up approach, that is 167 and to the base 8. So the next thing is if you want to convert the decimal number system into hexadecimal, we have to divide that particular number by using 16, and we have to write the reminders the same way from bottom up approach from bottom to top. So here the value of 11 in ASCII is B and the value of 14 in ASCII is E. So we have to write BE and to the base 16. We know, everyone, we know that how to convert this decimal number system, but we have to little bit, we feel little bit difficult in the part to convert this as a programming C code. So let I discuss how to convert this into a programming C. So as usual, we have to include the library function stdio.h, and we have to include the standard library function library lib.h, and we have to define here for converting the particular decimal number system into binary. I am just defining that through functions. So the first one we have to do the function prototype. We have to define the function. So here void to binary and void to octal and void to hexadecimal. In this particular function does not return any value to the main function. So I am defining that data type as void. As we know, void is a no return type. So here I am defining the first three statements is all about defining the function prototype. Then we are just coming inside the main and we are allocating the binary array as 50 and octal array is 50 and the variable is n and I. Here the hexadecimal is all about we are converting this particular value into character. In the previous slide we seen that the 14 is converted into E and 11 is converted into B. So if for that conversion, here we are declaring that hexadecimal as a character. Then we are getting the input from the user, enter the number to convert that value. So as usual, we are getting the number as integer and we are passing that particular integer to the binary function. Here, what it happens is binary function is taking an input. As we know, the particular, if I is equals to 0 means the value of the particular I that is present. If I am giving, for example, a particular value, that value will gets divided modulus by 2. The divided modulus by 2, the modulus means we will get the remainder of that particular value and it will be stored in that particular array. Then I need to extract that the last value. Okay, this is the codes, the explanation of the particular code. If I am getting the value of n is 11, what it is actually happening is the 11 modulus of 2. That is, the 11 modulus of 2 is 1. That 1 will be stored in the 0th position of this particular array. And I am just dividing that number. That is, the 11 divided by 2 is the n is equals to 5. In the next iteration, the 5 is giving as an input and the array will be, if we are here we are using for loop, the array will be, the I value will be incremented here. So In the next step, the I value is 1 and n is equals to 5. Here the binary of 1, here the array value is binary of I. So the binary of 1 is equals to my n value here is 5. So 5 modulus of 2. The 5 modulus of 2 is uh, reminder I'll get 1 here. So that 1 will be storing inside this the first position in an array. Then here n is equals to 5 divided by 2. The value of n is 2 here. Then likewise, the next iteration I is equals to 2 and n is equals to 2. Then after that, once I'll get the value of n is 1 here. The binary, the zeroth position, the second position of the particular array value will be gets us 0. And the last iteration, the value of I here is 3 and n is equals to 1. Here, if I am putting one modulus of 2 is obviously it is 1 and n is equals to 1 divided by 2. That is 0 0.5. It will consider only an integer part. So n is equals to 0. My iteration will be completed. So here I am getting the values in the binary array and I want to print that in a reverse manner actually. Why? Because my value here is if I am dividing 2 using 11 using this 2 is I will get the remainder value 5 hyphen 1. So I want to get it 1011. The value exact value is 1011. If I am reversing this array, I will get the 1011. So here I am just printing the array in a reverse order. For loop, I is equals to I minus 1. After completing this particular iteration, the I value will be um, incremented as 5. So I is equals to 5 minus 1 means the fourth position, the value which is present in the fourth position, that is 3, will be displayed first until 0. It will be displayed in a reverse order. For that purpose only here, the for loop will be executing in a reverse order. So this is the procedure for binary conversion. The same way what we have to do is we have to convert this an octal number also. As the same procedure, have to modulus, we are proceeding this octal. The octal of I is equals to n modulus of 8. In the previous case, we did n modulus of 2. In this case, we are doing n modulus of 8 and we are just reversing that array likewise we did in a previous. Actually, this is the step for converting. I am getting the value, n value is 55. We are doing just modulus of 8 and I am getting the first value is 7 and I am getting the second value is 6. So here I'll get the value in a reverse order, that is 67. 67. Here I defined how to do that in a uh, using pen and paper. So the value, the after the final value is 6 and 7, the array, in this array we are having 7 and 6. If you are writing that in a reverse order, we will get the exact answer. So for that purpose only here, the array is reversed again. For this octal also. The next one is hexadecimal. It is little bit tedious, but it is very easy actually. We want to convert that particular value into hexadecimal. For that, the code here is int reminder, comma I, quotient is equals to n and j is equals to 0. While quotient is not equals to 0, until that I have to execute this array. For example, if I am getting the value 190, here I am I am just assigning this n value into quotient. So the 190, I am assigning it into quotient. And in the first iteration, what I am doing is n is equals to 190. So I am checking the loop 190 is not equals to 0. Then as per the procedure, I am just getting the reminder value that 190 modulus of 16. 190 modulus of 16 is the reminder is 14 actually. And in the next case, I am checking whether 14 is less than 10. No, the 14 is not less than 10. Then what I am doing is I am getting inside the else part and I am just adding that particular value, that is hex of 0 is equals to 55 plus reminder. The value 55 plus reminder, 55 is constant here. The reminder value we get as 14. So 55 plus 14 is 16. As I already said, we are defining this hexadecimal into character. So 69 is stored as E in that particular array. So after that, the quotient, we are just getting the quotient. The quotient of 190 divided by 16 is 11.